Melanin
C18, H10, and 204.
by Esther Abdelsalon, Teresa Anderson, Chandler Dennis, and Corin Scott.
Melanin. Melanin is the chemical that gives skin its color after exposure to sunlight. Melanin can be found in the brain, it can be found in the skin, the eyes, the ears. The chemical structure is not completely known because there are so many different types of melanin. The two main categories of melanin that are found in humans are eumelanin, which is a brown or black color, and phenomelanin, which has a more red to yellow color. The subsequent color change in the skin depends on what type of melanin is most prominent in the affected person. Because people with dark skin, they tend to have lots of eumelanin, which is the brown color, and people with red hair tend to have lots of phenomelanin, which is the red to yellow color, and they also tend to have it in their skin as well. People who are albino have no melanin at all because they lack the enzyme that converts tyrosine to L-dopa, which is why they have such pale skin and hair. If you look at the first image, you can see that the person who has the smallest gray bar is most likely an albino or very light Caucasian because there's little to no melanin in the range. But if you see the person who has the highest gray block, they're really, really dark because they tend to have the highest amount of melanin in their skin. Melanin varies drastically by ethnicity. It ranges from 1 to 3% in light-skinned Caucasians and from 18 to 43% in dark-skinned Africans. If you look at the map on the slide, you'll see that the part of the world that is in the center has the darkest regions. That's because that's where the equator lies. And where the equator is, that has the most direct sunlight. So the people who are exposed to sunlight the longest are the people who tend to have the darker skin tones. And if you see as you go up or you go down in relation to the equator, you'll see that skin tone starts to get lighter and lighter, which means less and less sun is reaching those areas, which is why they have such light skin tones. How melanin relates to organic chemistry. Melanin is formed by the amino acid tyrosine, which is transformed by the enzyme tyrosine hydroxylase. Tyrosine is the first image you see on the slide, and then you can see the process of tyrosine being oxidized by tyrosine hydroxylase to form L-dopa, and L-dopa is dihydroxylene phenylalanine. The basic overall melanin molecule is a polymer of the oxidized L-dopa, so it's just the repeating structure over and over again. Like other organic molecules, melanin is triggered by the exposure to ultraviolet light, which is why eumelanin and phenomelanin can absorb light within the 500 nanometer to 900 nanometer range. The primary structure of eumelanin is a mixture of 5,6-dihydroxydienol and 5,6-hydroxydienol 2-carboxylic acid and two of the oxidized forms of each. The structure of eumelanin is on the bottom picture.
Melanin in people. Melanin is a pigment that is found in skin color and can be used to characterize the different skin color ranges that exist. It is made in cells called melanocytes that can be found in the skin layer called the epidermis. Lighter skin color is known to have less pigment, which can be due to the type of melanin that the person produces or the number of melanocytes that they have. If they have less melanocytes, then they hold less pigment, but if they have a lot of melanocytes, then they can hold a lot more. Vitiligo is a condition in which the skin begins losing these melanocytes in patches, and the picture in the bottom right corner shows somebody with vitiligo. Light-skinned people and dark-skinned people both have melanin, but it's the type of melanin that they produce that causes them to differ. Pheomelanin, which is the melanin in the red to yellow range, is what lighter-skinned people produce more of. But eumelanin, which is in the brown to black range, is what darker-skinned people produce more of. What melanin does in the skin. Melanin's main function is to scatter UV light, preventing a lot of it from going past the epidermis and farther into the skin. In darker skinned people with more melanin, the pigment can't be broken down by enzymes, allowing it to remain intact and carry out this function for long periods of time. Melanin's main function is also to protect from UV radiation. People native to tropical regions of the world where there is no forests and UV radiation from the sun is particularly intense have darker skin because the melanin acts as a protective barrier so that they do not suffer from this UV exposure and get skin cancer.
The role of melanin in skin cancer. UV radiation causes DNA damage to melanocytes, which are the skin cells that produce the skin pigment known as melanin. Melanin is protective pigment in our skin, and it blocks our skin from UV radiation, which could potentially cause us skin cancer. Melanin does protect us, but some research has recently shown that melanin could also do harm to our skin. How melanin can hurt us. Researchers say UV radiation generates reactive oxygen and nitrogen that energizes an electron in melanin. That energy can cause DNA lesions, which can lead to cancer-causing mutations. The lesions typically appear less than 1 second after UV radiation exposure. Dr. Brash, a skin cancer researcher at the Yale School of Medicine, says that melanin has two opposing things happening at the same time. Melanin can both protect us and damage us. Dr. Brash's team is looking to create a product that can suppress the reaction of the melanin to cause cancer-causing mutations. It would be like an evening after sunscreen. People could apply it like moisturizer when they came out of the sun. This is a skin type chart. It shows the increasing amount of pigment that people have in their skin tone. Darker people tend to have more melanin, so they have a lower risk of skin cancer, whereas more fair people have a higher risk of skin cancer. This is due to the fact that the UV radiation is more susceptible when you have a lighter skin tone than a darker skin tone because you have more melanin to block the UV rays.
We are all very familiar with the phenomenon where apples turn brown after we eat them or after we cut them for a while. There are two types of browning: enzymatic and non-enzymatic browning. Apples are a case of enzymatic browning, and the Maillard reaction, which we covered in an earlier Relife Orgo, would be an example of a non-enzymatic browning. When we cut into an apple, cells get damaged and polyphenol oxidase and polyphenols react. Polyphenol oxidase and polyphenol can be found in any apple, but from the outside, it's not brown. This is because until they get cut, they are separated. Polyphenol oxidase can be found in chloroplasts, and polyphenols are found in vacuoles. Because of this, they're separated, so they're not reacting with each other. Phenol oxidase is a very common browning enzyme, classifying this as an enzymatic browning. Once the apple is cut or we bite into it, it is exposed to air, so oxygen is now added. When polyphenol oxidase, and oxygen mix, an O-quinone is formed. The O-quinone will polymerize to form melanin. On the bottom of this slide, you can see the overall reaction for a polyphenol reacting with polyphenol oxidase and oxygen to form a type of O-quinone, and then polymerization happening to later form a melanin, which is a brown pigment. On this next slide, we see a more detailed mechanism of the reaction from polyphenol to O-quinone to ultimately melanin. So obviously, it is undesirable for our apples, our fruits, our vegetables to brown, and so there are a few ways that we can prevent this from happening. We wouldn't want everything to mix together, so we would want to stop the reaction from polyphenol all the way to melanin. Ways we could do this would be storing an apple in a high temperature. At high temperatures, polyphenol oxidase cannot polymerize, and ultimately we cannot form melanin. In addition, polyphenol oxidase contains copper ions, which are very much involved in the browning process. Citric acid is a chelating agent, which means the ions would get tied up so they can't react. So this is oftentimes why some people will spray lemon juice on their apples or their vegetables, because the chelating agent that is in the citric acid will tie up the copper ions so they cannot break out of the polyphenol oxidase, and because of that, we cannot brown. They do not have one of the things that they need to brown fruits or vegetables. But the browning of apples is definitely seen as undesirable. However, polyphenol oxidase is also responsible for brown colors we desire, like in coffee and tea.